Hey guys, it's Miss Ghetto here. Welcome to my channel. In this video, we are going to be simplifying radicals. Specifically, we're going to be simplifying square roots, cube roots, and fourth roots. Let's get started with a quick review of the different parts of a radical. So you may or may not have seen radicals before. Usually this is what they look like. This is the radical symbol right here. The number that's outside the radical symbol is called the index. Usually it's a little small number on the outside. If you look at this star on the top right corner, the index in this case is the 3. If there is no index or there's no number written outside the radical symbol, it's assumed that it is a 2. So square roots, the index for square roots are always 2. And then the number that's underneath the radical symbol is called the radicand. One thing to keep in mind, as we are simplifying radicals, we're going to be using perfect squares, perfect cubes, and perfect fourths to help us. Let's go ahead and get started with square roots. So number 1, the square root of 180. To simplify this, I need to find the factors of 180, and I'm looking specifically for factors of 180 that are perfect square. So I know that 1 times 180 is 180. I know that 2 times 90 is 180. And I can keep going with the list, but I'm looking for the one that's perfect square, the largest perfect square. 5 times 36 is also 180, and I notice 36 is a perfect square. So I'm going to rewrite the square root of 180 as the square root of 36 times the square root of 5. And the square root of 36 is 6. So this becomes 6 square root of 5. And that is my answer. If you have a number in front, a coefficient, you're just going to multiply that. So let's look at number 2, negative 8 square root of 63. So I'm going to break down the square root of 63, and I'm looking for factors of 63 that are perfect squares. I know that 9 times 7 is 63, and 9 is a perfect square. So I'm going to use 9 and 7. So I can rewrite the square root of 63 as the square root of 9 times the square root of 7. And then I'm just going to bring down negative 8 and multiply. So the square root of 9 is 3, so this becomes negative 8 times 3 square root of 7. Negative 8 times 3 is negative 24, so my final answer is negative 24 square root of 7. And that is it. Now we're going to take a look at cube roots. So with cube roots, I'm looking for what number can I multiply by itself 3 times to give me the radicand. So I have my perfect cubes out to the side to kind of help me break these down. And a lot of times with the cubes and fourths, you're going to have large numbers. So let's look at number 3, the cube root of 128. So I need to find the factors of 128. You can definitely use your calculator to find the factors, especially when you have large numbers. It helps to use a calculator. So my factors of 128 are 1 times 128, 2 times 64.
What else? 4 times 32. Let's see, are there any more? 8 times 16. And it looks like those are also.
So which one of these, if any, are perfect cubes? And it looks like my largest perfect cube would be 64. So that means I'm going to rewrite the cube root of 128 as the cube root of 64 times the cube root of 2, because 64 times 2 is 128. And I know what the cube root of 64 is, so I can always reference my chart over here on the side, the cube root of 64 is 4. So this becomes 4 cube root of 2. And that is my answer. Let's take a look at number 4, 5 cube root of 192. So this time I am looking for the factors of 192, and I'm looking to see if any of these are perfect cubes. So what are my factors of 192? Let's see. 1 and, of course, 1 is always a factor. 1 and 192.
296. 3 times 64, so I see 64, that one's a perfect cube, but I just want to double check to see if there's anything larger. So 4 and 48. And of course this is a larger number, so of course there's going to be more factors. 6 and 32. 8 and 24. 12 and 16. So
it looks like 3 and 64 is the largest. So I'm going to use 3 and 64. So I can rewrite the cube root of 192 as the cube root of 64 times the cube root of 3. Because 64 times 3 is 192. If you have a coefficient in front, so like this 5, you just bring that down in front. So this will be 5, oops, gotta get the right color here. 5 times the cube root of 64 times the cube root of 3. The cube root of 64 again is 4, so this is 5 times 4 cube root of 3. 5 times 4 is 20, so this is 20 cube root of 3. And that is my answer. Now let's take a look at fourths. So notice that on my little cheat sheet here out to the right with perfect fourths, the numbers get larger a lot quicker. Again, the process is still the same, so I'm going to look at number 5, the fourth root of 80. So I'm looking to see, is there a number I can multiply by itself 4 times to get 80? And the answer is no, because it's not a perfect fourth. So again, I have to break this down, and I have to look for the factors of 80. And I'm looking to see, are any of the factors of 80 perfect fourths? Again, you can always use your calculator. I can rewrite the fourth root of 80 as the fourth root of 16 times the fourth root of 5, because 16 times 5 is 80. So I'm going to rewrite this as the fourth root of 16 times the fourth root of 5. And the fourth root of 16 is 2, so this is 2 fourth root of 5. And that is my answer. Number 6, negative 3 fourth root of 243. So I have a larger number again, 243. I need to look for the factors of 243, if any of them are perfect squares. So 243, I can rewrite that as the fourth root of 81 times the fourth root of 3, because 81 is a perfect fourth. So if you have a coefficient, you always bring that down. So this becomes negative 3 times the fourth root of 81 times the fourth root of 3. And the fourth root of 81 is 3, so this becomes negative 3, oops, gotta get the right pen, negative 3 times 3 times the fourth root of 3. And negative 3 times 3 is negative 9, so this is negative 9 fourth root of 3. And that is my answer.